We're here at AUVSI 2014 in Orlando with Curtis Reichenfeld of Curtiss-Wright. Thanks for being here. I'd like to ask you a couple questions. You're here at the show AUVSI. I think you've been a number of years here. What is about the show that is important to you? Why is it important for you guys to be here and exhibit?
Well, a lot of our embedded systems and COTS modules and things like that are used in a majority of these UAVs. What's important to us here, we've been coming here for many years, like you said. We've been supporting the Northrop Grumman on the Global Hawk program back from the Tier 2 days. But we do mission computers, flight control computers, and all the ISR payload management in open architectures. And we've been increasing power and performance throughout the years, right up to the Triton in the MAMS program.
Right, of course, right, yeah. I guess, probably more than any type of military platforms, really, unmanned systems depend on embedded computing because basically, there's more automation, there's more demand, and things like you talked about, like the ISR and everything, there's always more appetite for more processing power, that kind of stuff.
Yes.
So what are some of the opportunities for that technology and unmanned systems that you see going ahead?
Some of the things we're seeing is we have to work with some limited data pipes.
Yeah.
They will get more bandwidth over the years, but currently we try to do more onboard processing of data so that we can get the right information to the right people at the right time rather than blasting the pipe with a ton of data. So that onboard processing section and being able to be more autonomous, being able to do more collaborative between UAV aircraft and like a swarm type formation.
Yeah, maybe some manned vehicles too. That kind of stuff together.
Collaborative manned unmanned sorties together, working together on different parts of the mission. It's getting very important.
So much more sophisticated than years ago, where they just use it for reconnaissance and video. They're really kind of making a whole system and operations going on. So inside these systems, obviously Curtiss-Wright and the whole industry was all based on single board computers, board levels. That was sort of the center of the industry.
Right.
Now these sort of box level systems are becoming a very important part too. Not replacing board level stuff, but the sort of specialty box and that sort of stuff is really becoming a different option, different choice. And can you go through for me how do they sort of position themselves in these type of systems?
Yeah, I think there's both systems and they're very complementary to each other depending on the mission, the size of the UAV, size, weight, power, cost, obviously, depending on the UAV. Larger module-based systems with open architectures make it easily upgradable.
Right.
Advanced processors when the new processors come along, increasing the I/O, and having that modularity allows you to do technology refresh and obsolescence management. And then the smaller boxes, I will call them more application specific, where an Ethernet switch doesn't really need to have modularity in terms of a standalone, and smaller boxes and that need to fit in the smaller size UAVs, the little nooks and crannies that are available to them, make it important to have more optimized systems for those types of things.
Yeah, so definitely there's situations where you don't want a backplane with a bunch of slot cards, but then there's sort of legacy systems where it's really nice to be able to just upgrade with a new processor board and go on another 10 years with it. That's the choice they want to make.
Like I said, the increased embedded performance and the hunger for more power
is always there.
And the COTS industry is keeping up with the latest technologies, the Intel and the PowerPC base. Even starting to work on ARM-based processors. So.
Yeah, of course. And I know you guys have some of that stuff too. So let's talk about, you talked about the whole network-centric operation stuff. There's sort of a whole signal chain of like the data collection, the storage of the information, sending where you want to go. That's you guys actually play in lots of those areas with different products and that kind of stuff. How do you see those supporting this whole trend of what they're trying to do? I guess there's going to be a network node in every situation, whether it be a soldier with a radio or their vehicle or that kind of stuff, or a Navy ship. So there's really points along the way. How do you support that? Big picture stuff.
The big picture stuff, it's all over the network. You start with network-centric architectures, backplane fabrics in the LRUs. Within the vehicles, they're all connected by high-speed data buses, Ethernet, things like that, where it's more networked. And then externally through the communication links and satellite links, they're getting more cooperative data to the right place at the right time, like I said. So even a UAV flying over a area of interest can be seen on the naval ship, or it can be seen by ground troops all at the same time over the network. So,
Yeah, they want to make use of all of it. Yeah. So some of the technology we talked about, I mean, this whole idea of swap, size, weight, and power, reducing that, it's always going to be a challenge, and it's in the requirements of almost every design these days. But the challenge is always there because they're using processors that are more powerful, usually drawing more wattage and that kind of stuff.
Right.
What are some of the sort of pluses and minuses and challenges that you really have to get through to feed those requirements or meet them?
Yeah, some of the components they're coming out with, higher speed blade processors and things like that.
Yeah.
The power and heat and performance are going up.
Yeah.
And then on the other end of the market, the iPhones and the iPads and the mobile commercial
going down,
technology are getting smaller and lower power,
Yeah.
but with enough performance that you kind of have to do a trade between which technologies for the particular mission you want to do.
Okay.
So, and the trick there is to figure out how to ruggedize some more of those commercial components,
Right.
because we don't have the military components anymore.
Yeah.
And the other situation for military UAVs is to maintain configuration management, obsolescence management.
Right. You take on that burden essentially,
We
right?
do take on that burden.
Yeah. And as you said, I mean, all these semiconductors, the processors, the memories, they're really made for the consumer market, and they really don't care about, temperature and ruggedness, that kind of stuff. So, but you have to sort of use that in your systems, right?
We still have the minus 40 to plus 71 degrees environments. Some of these UAVs are flying near space.
Yeah.
So we have to worry about radiation and single event upsets and things like that. So there's
And beyond
different problems.
whole different problems. And there's also the system side. I mean, also there's cooling problems at the closure level and that kind of stuff, and advanced techniques to sort of look at it from the systems level too, because maybe having a box level cooling issue rather than inside, that type of stuff. Yeah.
Yeah.
So okay, well, thanks, appreciate it.